Okay, we're going to look at even and odd functions. So we define a function to be even if we can plug negative x in for x and end up with a result that is the same as the function. What this means graphically is that it's going to be symmetrical over the y-axis. So let's take a look at an example here. Here is a very simple example. F of x equals x squared. So to determine if this is even or not, what we're going to do is we're going to drop in a negative x where we see an x. So if I substitute in negative x where I see an x, notice the result we get is the same as f of x. So this fact up here is true. F of negative x is the same as f of x. Now, graphically, understand what's happening. Of course, we know that x squared looks like that. If we were to consider a couple points, consider the point 3, 9. Well, we know that if we were to look at the x value of 3 and negate it, well, now we're looking at negative 3. And if we plug negative 3 into that function and square it, we still get 9. So notice how it's symmetrical over the y-axis. Okay, symmetrical over that line. Let's take a look at another example. We have f of x defined as x to the fourth plus x cubed. So if we're trying to determine if this is even, what we're going to do is we're going to once again find f of negative x. So that simply means we're going to substitute in a negative x everywhere we see an x, and then we're going to simplify it. So since we have an even power to start, that's going to stay x to the fourth, and then this negative x cubed, that's going to turn into a negative x to the third. Now notice that this result is not the same as what we started with. Okay, this is not equal to f of x. So therefore, this is not even. Okay, next let's take a look at our definition for an odd function. So we say a function is odd if f of negative x is equal to the negation of the original function. So in other words, we're going to drop a negative x into the function again. If our final result is the negation of what you started with, then we say a function is odd. Now, geometrically, what this means is it's symmetrical over the origin. Okay? And by the way, if something is symmetrical over the origin, we're really talking about a rotation of 180 degrees. So let's look at an example. Here's a pretty simple one. F of x equals x cubed. So the test here is to plug in negative x, just like it was for the even functions. So if we plug in negative x, notice our final result here is negative x cubed. And notice how that is the negation of what we started with, f of x. So therefore, we say this is an odd function. Now graphically, if we were to take a look at this, here is our graph of x cubed. So if we're looking at a point up here, such as 2, 8, okay, 2 cubed is 8. If we were to negate the x value of 2, we would have negative 2. If we plug negative 2 back into the function, notice we get the negation of the y value. And here we're showing that it's really symmetrical over the origin. Here's another example of a function where, let's suppose we're trying to determine if this is even or odd. So the test is always to plug in negative x. So if I plug in negative x here, I get negative x plus 3. Now notice that this is not the same as the original function, and it's also not the same as the negation of the original function. Okay, a certain part of it is negated, but we don't have both terms negated, right? That 3 is not negated. So therefore, this is neither even nor odd. So you're not always guaranteed to have a function be either even or odd. And finally, if we were to talk about our 6 main trig functions, if you were to look at the graphs of these functions, you would notice that cosine and its reciprocal secant, remember secant's 1 over cosine, those are even functions because they're symmetrical over the y-axis. Likewise, if you were to look at sine and its reciprocal function, cosecant, and tangent and cotangent, those are odd functions. Those are symmetrical over the origin.